फर्स्ट पासून स्टार्ट करू.
हाँ.
So, hello everyone. My topic is fine tuning LLMs and efficient prompt engineering. Under this, we will see what is meant by LLM and efficient prompt engineering. And there is one model like Hugging Face model. We will see under this. So, first of all, what is LLM or introduction to LLMs? So, LLM is nothing but a AI model which we trained on vast amount of text data which generate human-like language and perform a wide range of NLP tasks. We all know that there are different types of examples of LLMs like GPT-3, GPT-4, BERT, T5, and many more. Each this LLM with their own unique architecture and capabilities under this model scaling. The size and complexity of LLMs, like their own, is grown exponentially, leading to advancement in language understanding and generation. So we can scale our model based on this by use under this LLMs based on their size and complexity. So we have seen the definition and examples. Now the capabilities. LLM can perform a wide range of NLP tasks. There are many tasks like summarization, translation to sentiment analysis and code generation and many more. We can LLM is capable of doing all these tasks and many more tasks. We also know what are the importance of LLMs in NLP tasks. So first one is versatility. LLMs can be applied to it can perform the wide range of NLP tasks, which makes it a invaluable tool for NLP understanding and generation. Second importance is performance. By using the LLM, we can increase the model accuracy and its performance uh, across the various NLP benchmarks. The third one is flexibility. LLMs can be fine-tuned or adapted to specific domains and tasks, making them highly versatile and customizable. LLMs are highly versatile and customizable as per customers like requirement. We can perform LLM can perform the task. Generalization. LLM exhibit remarkable ability to generalize and apply their knowledge to new and unseen data, and it generates the new data based on our requirement. The next one is fine tuning. So first of all, we should know about LLM. LLM is nothing but suppose chat GPT 3 is there, 4 is there. So first of all, we just trained a large or a vast amount of data on this LLM. But what is meant by fine tuning? Fine tuning means on the specific area or specific domain we are training our model. Fine tuning is nothing but a pre-trained weights of a large LLM, and it adapts to a specific task or specific domain by training a smaller, like a task specific data set. Training from scratch builds a language model from the ground up by training on a large data set without relying on pre-trained weights. Instead of training from scratch, in case of LLMs, we can use the Hugging Face data model. Actually, in Hugging Face model, there are many various types of models are included under this, so that we just don't need to start from the scratch, or we can use directly this Hugging Face model, so that LLMs don't need to start from the scratch. We'll see this in the next slides. And trade-off is nothing but fine tuning is generally more efficient and effective. While training from the scratch, uh, we are uh, um, we are improving the performance, but it requires a large amount of memory, we can say that, and computing resources or all that, or we require more data for this purpose. So key concepts and steps for fine tuning. As we know that for every purpose, we first prepare our data, and under this, we just remove the null values and outliers and something like we prepare just all our data under this. After this model selection, based on our pre-trained LLM as a starting point, we consider our model ka size, architecture, and its performance on relevant tasks. And based on our requirement, we select a particular model. And then fine tuning. Train the we train he, In fine tuning we train the selected LLM on task specific dataset, as I told you earlier, allowing the model to adapt and specialize for the target application. So, on specific when we are training a selected LLM on specific data set, it is nothing but a fine tuning. And evaluation is nothing but we are calculating the performance and accuracy, F1 score, everything comes under this evaluation point. So prompt. So prompt is nothing but we prompt composition under this, crafting effective prompts that guide the LLM to generate desired output, where we consider the different factors like context, tone, and task-specific instructions. But this prompt should be clear. Means if you say just write a poem, then it will write any poem. But if you want something poem, then we should write the name of that poem. So it should be clear what we want. So that LLM will provide the output, desired output as what we want. So prompt tuning under this, iteratively refining and optimizing prompts so that accuracy will get also improved, and we will get the output which we want from the LLM. Prompt automation, it is nothing but developing a systematic approach to generate uh, prompts and at scale, like where we leveraging the techniques like the prompt templates and prompt libraries. So best practices for the prompt engineering. As I told you, clarity and specificity. Prompt should be clear, concise, and provide the specific instructions to the LLM, and it should minimize the ambiguity. There should not be any ambiguity, so that LLM do not understand what we want, so that it will give something like wrong output. So for this, clarity and specificity is important. Context and framing. Under this, incorporate relevant context and framing to guide the LLM towards the desired tone. Desired tone means like if we want formal language, informal tone, anything, formality, levels of formality, style, whatever we want, we should provide that to the LLM so that it will give desired output. Iterative refinement means we are testing that iteratively to increase the performance of the prompts. As I told you, Hugging Face model is used in for LLM fine tuning, so that we just don't need to start from the scratch, and so that we can easily cover. We just don't need to start from scratch, and whenever we start from scratch, we require the computing resources, we require the data. So by using this Hugging Face model, we can reduce all these disadvantages, we can say that. So developers mostly chooses this model so that it fits their needs, and we'll see the next one, transformers library for customization and fine tuning. Under this, transformers library allow developers to easily adjust existing model. For example, they can change how the model learn from the data, adapts to it, it work better for specific application or not, something like that. Simple fine tuning. Uh, with just a few lines of code, a developer can fine tune models on their own dataset, unlocking the power of transfer learning. So fine tuning is the process of training a model on a smaller or specific data set to improve its performance on related tasks. So transformer libraries simplifies with this by using a straightforward code that allow developers to fine tune models quickly without reading a deep without going in deep. Under the streamline, the library seamless integration with deployment frameworks makes it easy to integrate fine-tuned models into production system. Means after fine-tuning, models need to be put into use such that we use mobile application or mobile apps. The library should make it easy to integrate these models into our existing systems, uh, ensuring that our work should be smoothly in real world case scenarios. So datasets library for the dataset management. Under this diverse dataset catalog, the dataset library provides access to a vast collection of high quality datasets covering a wide range of domains and languages. So library provides access to a wide variety of dataset, language and tasks. This is important because having good data is too essential for training effective models. So easy data loading. Developers can quickly load and pre-process the data set with a few lines of code, saving the valuable our time and effort. So this is the we can say use of dataset library. So flexible customization. It provides the flexible customization to for easy creation and manipulation of custom data set, so that we concentrate on specific data, specific domain, specific model, and streamlined versioning. Sets can be tracked over time, which is important for collaboration. If dataset changes, developer can see what had changed and use specific versions, ensuring reproducibility in their experiments. So dataset can be versioned and shared, promoting collaboration and reproducibility in the machine learning community. Trainer class for streamlined fine tuning, all in one solution. Trainer class simplifies the fine tuning process. We used for one trainer class which simplifies the fine tuning process under this, which handles the like model ka training, evaluation, checkpoint saving. There are many parameters we used in this. Automatic optimization class automatically handles the hyperparameter tuning, resource management, reducing the complexity of fine-tuning pipeline. It provides the flexible customization. Developers can easily extend the trainer class to implement custom training, loop, and metrics for their specific needs. Uh, as prompt optimization with Hugging Face tool can provide the prompts search, which provide high performance prompt tuning. Under this, we are refining and optimizing prompts and prompt analysis. Under this, we are getting the insights of the prompt performance with their analysis suite. So, uh, by using the Hugging Face model, I have just implemented a simple code. Just go through that. Is it visible? Yeah, no? Okay. So, first we will install all libraries like pip install transformers. This is used for LLM uh, like requirements or dataset for dataset, and WangDB is like weights and basis for visualization purpose, or for saving our project ka like data, everything like whatever in our project, how much CPU utilization is done, how much memory is used. Based on that, it will draw graphs and something like that. After that, WangDB is imported here from transformers. We have imported Atom model for causal LM. So this is one of the language model which we have imported, and auto tokenizer for tokenizing purpose. As we know that we can convert the text into some like numerical form. Trainer for training the dataset, and training arguments contain some arguments. From dataset, we have imported the dataset. Torch is a Python library which is used for improving the performance, particularly purpose. WanDB login. I've just signed up through WanDB and just created one account, and I've just logged in by using this code WanDB.login, and initialize or wait and base WanDB run by using the init method, where I have just given a project. Code is not visible. Okay, just wait. Sorry, code is not visible. Is it visible now? Hello, Aditya, just see this.
Uh, no, code is not visible.
अभी भी नहीं? मैंने जूम किया है. नहीं?
Actually, only PPT is visible.
अच्छा अच्छा अच्छा. Just wait. हाँ. Okay. I think it should be visible now. Just wait. Is it visible now? Hello?
Yes.
हाँ. So yeah, I just created account there, VanDB, and I just log in by using this code where I have initialized by using the project. I just get given a name like a GPP. दिख रहा है ना अच्छे से? So under this, I have just given a project a name as GPP. So yeah, it's showing some like currently logged in as Guy UPP 11. This is my mail username particularly. This is my college name, and it's showing the version. And after this, we can view the project at these given links also, and we can see this by using I deploy option here only. You can see this here. So this is under the workspace. In case of evaluation, it will give, there are four panes actually: evaluation and train. So under evaluation, we can see the, just wait, very अच्छा दिख रहा है, just wait. हाँ. So on the workplace, there are actually different panels. Evaluation, under evaluation panel, we are just checking like evaluation means validation, testing. Like evaluation loss का ये graph है. How many steps per second they have taken. Based on that, they have drawn this graph. Samples taken per second based on this graph, and evaluation per runtime. Based on that, we'll see this in the upcoming code, but just see these graphs. Train per epoch. Epoch means a particular pass. In one pass, how much we have trained or something like that. Based on that, they have drawn some graph. And based on systems, we can like network traffic, disk utilization, CPU ka utilization, process CPU threads in use. Based on that, just they have drawn these graphs. And there are many like whatever this in we can save the any project info by using this VanDB. So yeah, it does not have jobs and jobs नहीं हुआ है ना. So yeah, we can see various, we can create reports here also. So yeah, this is all about the overview of the PanDB. Here you can see also in the overview section the project's feasibility. If we can here see like total runs, how many are done until now. Until I have created yesterday this account, so yeah, only 3 runs are. So total compute is 6 minutes. So yeah, we can see this all. So after this, it's good. I have just created a data set from a dictionary by using like sample text 1, 2, 3 under this, and we need to convert the dictionary into the Hugging Face data set because we are using the Hugging Face data set under the in this code. Then we have done the trend test split where zero test size is 0.2 for means 20% and 80% split is there. 20% for training and like this train data set, we know this now, train test plate or train under this, I just save in this variable train data set, evaluation data set. After this, model name is GPT-2. Model is like here we have just use this causal language model from pretend where model name whatever we are using will go under this, and we are tokenizing this. This is done. Pack token ID is set to EOS token ID. This is done to improve the performance. Here one a tokenization function is uh, created. Uh, so yeah, this is for creating the labels and adding these labels to the tokenized output and return the output. Tokenized train dataset. Under this, we are doing the mapping of tokenized function, whatever the we got from the train dataset and whatever we got from the evaluation dataset means validation testing. So this mapping is done here. After that, we are preparing training arguments. We have just taken one output directory evaluation strategies epoch. As I told you, epoch means one pass from starting to end. So in learning rate is also given. So yeah, per device, how many like batch size kitna hai, how much epoches we can do. Here three epoches are done. Weight weight 0.01. And this is all about log to weight and biases. Initialize, we have just initialized the trainer where model is given, training arguments, token train dataset. Under this tokenized train dataset, evaluation dataset, tokenized evaluation. It includes the evaluation dataset here. After that, I trained the model where two types of there are, as I told you, there are three epoches. So one epoch, two epoch, three epoch. Training loss. Training loss is there is no any training loss, but there is a validation loss. So for each epoch, it is given. We can reduce this by using the another model as per our requirements or something like that. We can reduce this validation loss also. If validation loss is like low, the better is the model. And we just save this model in the fine tune model direct. So this is my implementation. I just need to stop recording first of all. Thank you.